Excellent. Awesome. Well, it's so wonderful to see all of you this Friday afternoon to talk about hydrogen. Wanted to spend a couple minutes introducing myself. I can introduce my organization, tell you what we do, and then I'll pass it off to my other panelists to talk about themselves. I'm Julia Thayne. I'm Senior Principal with the Climate Aligned Industries Program at RMI, or Rocky Mountain Institute. RMI, how many of you have heard of it? Show hands. Okay, a lot of people. I'm still going to explain it to those of you who know, and also those of you who don't. It is a 40-year-old global climate nonprofit that focuses on accelerating the clean energy transition for all. A couple of things make us distinctive. So one is we have a market-based transformation approach. That means we believe heavily in policy, in finance, in technology, and community engagement as ways of bringing forward solutions faster so that we can achieve 1.5 degree alignment by 2030, or hopefully achieve 1.5 degree alignment by 2030. The second is that we believe in data. So in God we trust, all of us bring data. And really focus a lot of our research on modeling, on significant technical analysis. And then the third thing, which is kind of the reason I joined RMI, is we believe in applied hope. So the idea that you don't depress people into action, that you really have to organize people around some sort of vision that gives people hope and that gives people agency. The organization itself and MBA students are more than welcome to apply. We have many MBAs who are at RMI. Is about 700 people. We're $150 million a year. We're based in the US, but half of our staff is outside the US. Because of the size of us, we're about in the top 5% of nonprofits in the US. This is not news to you all, but heavy industry and transport sectors are now responsible for nearly a third of global emissions. They're going to grow. And demand reduction, energy efficiency, things that we talk about in other sectors are still applicable in heavy industry and transport, but we are still going to see significant growth, which is why we have this team that focuses on the hard-to-abate sectors, so the 8 industrial sectors that you see up on the screen. And the way that we organize ourselves is we think about 3 cross-cutting focus areas, so things like hydrogen, things like carbon capture and removal, and things like first projects, recognizing that we have not nearly enough of these large-scale commercial projects that we need to demonstrate how we can scale. And then we think about technology, finance, community engagement, and policy. Wanted to mention, you all may also know clean hydrogen is a huge investment opportunity. We have a point of view. So our point of view is that chemicals, fertilizers, and steel are going to drive demand in the near term, that transportation, so trucking, aviation, shipping, is going to be medium to long term, and that exports, especially with the Inflation Reduction Act, is something we need to focus on right now in the US, but for targeting Europe and Asia in particular. These are 4 things that we do when it comes to our hydrogen capabilities, market research, models and tools, policy insights. And the work that I'm leading right now is a 2-year, $24 million grant that we got from Bezos Earth Fund to build out hubs. So these are words that that's a word that you're very familiar with being in the clean energy space, but it's basically a place-based approach to bringing together the producers, to bringing together the off-takers, to connecting them with physical and, for that matter, social infrastructure, and things like finance, policy, and community engagement. So right now, this grant allows us to work in Houston and Los Angeles. We're actually supporting 27 project developers directly with pro bono advisory support, so learning incredible amounts of things around how do you decarbonize cement processing facilities, how do you build a globally relevant SAF facility, how do you think about green hydrogen versus blue hydrogen, and doing so again in California and in the US Gulf Coast. So I'll stop there and I'll pass it over to the next panelist to introduce themselves, which is Jawaad. Yeah.
All right. Thanks, Julia. Again, great to be here. I've only got 99 slides. Yeah, all right. Just a little bit about SoCalGas. I think everybody here is a customer of SoCalGas. If not, we'll talk about it afterwards. We've been in business over 150 years. So talk about energy transition. We've been in a transition since the last 150 years. We started as a streetlight company. We had propane. Street synthetic gas, and now sort of natural gas, now looking at ways to decarbonize that fuel. Serve over 24,000 square miles, so all the way up from close to Fresno all the way down to the Mexican border, and then over 21 million customers. So we take our role in this very seriously. We impact a lot of homes, a lot of businesses. All the areas that Julia talked about, we're also looking at as well. Just a quick strategic overview of what the journey has been for me in this role as Chief Strategy and Sustainability Officer. Back in 2021, we released our climate goal, which is Aspire 2045. It's really to get to net zero by 2045 in all of our operations. It is the largest and one of the first gas-only utilities to put that out there. And really it's to lean in where the state is going. Like, you can't have a goal that's 2050 when the state has a goal for 2045. So we're leaned in there. We followed it up with what we call our Clean Fuels White Paper, but essentially it's a pathways analysis that we did for the state of California. Looked at all the multiple ways we can achieve net zero across the entire economic sector, not just residential buildings, but aviation, transportation, et cetera. And really the quick takeaway was it's going to take all the above. A lot of solar, a lot of wind, carbon capture, RNG, renewable hydrogen, carbon capture, batteries, and that's going to be the most efficient, most affordable, and most resilient way to get to net zero. Over on the right side, since 2022, we've had a couple of a good direction as it comes to hydrogen, and I'll talk about these as we have our discussion. But the big project that we have going on is a backbone project. It's a natural gas or pure green hydrogen transmission line that we're working on. It's called Angeles Link. I'll talk more about that. We also set up the first hydrogen-powered microgrid. It's a home that's powered by hydrogen, but it's really to demonstrate what it could look like if you can support up to 100 homes, and I'll spend some more time on that as well. And then last but not least, Julia talked about this a little bit, but we're really excited about California and ARCHES, which is the consortium that's working on the California Hydrogen Hub here. We're partners in that. We're really excited about how we can partner and leverage our infrastructure expertise in that space. Last but not least, we're also looking at a blending application in coordination with the state of California, the PUC, and all the other gas utilities to start demonstrating small amounts of hydrogen blending and demonstrate that for safety and viability. Lastly, just to set up where we're going to be going in this discussion, Julie, I think we have the same slides. We can talk afterwards. But again, I think we're also looking at decarbonization for hard-to-abate sectors using hydrogen. Power generation, given where the state's goals are for clean power generation, we feel that's going to be a big demand center. We talked about transportation a little bit. Arnaud's going to talk a lot about it. And then industrial decarbonization. The funny thing about that one is that the LA basin or the LA area is the largest manufacturing center in the USA. There's more manufacturing jobs in LA than acting jobs. A lot of people don't know that. There's a lot of industry that needs to be decarbonized. I think hydrogen has a good role to play there. So, Arnaud.
Thank you, Jawaad. What I love about these panels is that we need all of us to make it happen, and it's always complementary. Let me start by telling you why I'm in hydrogen aviation. So I'm Arnaud, I'm the Chief Operating Officer of Universal Hydrogen. And so why I'm in this space is because I've been trying personally to reduce my emissions. So I've got an electric car, electric motorcycle, an electric house, the solar panels to full of that, and all of that is 20% of my emissions. 80% of my emissions is flying for business reasons or personal reasons. I'm from France, so I travel a lot, and therefore it's for me in my heart where I need to be able to, for the industry to decarbonize the aviation space truly, to be able to make a big dent in that sector. And to decarbonize aviation, there's three major methods that are today in the works. There's electrification. Electrification is good for, I say, short-range, small distances, not a huge amount of passengers considering the battery technologies today. There's hydrogen, which is an excellent fuel for like a mid-range, 2,000 miles, 100 passenger, 200 passenger application. And then there's sustainable aviation fuel for what you can't decarbonize with either electrical or hydrogen, which is both hydrogen and electrical are zero emission. Sustainable aviation fuel is not fully zero emission, but is a good step forward for everything that you can't do with hydrogen or aviation. And so our job is like, okay, how can we get there as fast as possible to decarbonize the aviation space? And you need three things. You need it to be green or low carbon intensity hydrogen, which is the first. So we partner with a lot of the projects that are sponsored and supported by the hubs, by the industries to be able to create that low carbon hydrogen. Then you need products to be able to use that hydrogen as a source of fuel, so aircraft applications or ground applications. And then actually what's been blocking the transition of aviation to hydrogen is not the technology from an aircraft perspective, it's how do you transport the hydrogen from the source of production to the aircraft. There's no pipelines. If you want to fuel hydrogen as how jet fuel is fueled today, it's trillions of dollars of infrastructure that needs to be implemented at the same time on all of the airports because the airlines fly their aircraft from airport to airport. And so if we look at the industry today very quickly, low carbon hydrogen production is scaling very widely throughout the world. You heard this morning about the IRA, the Inflation Reduction Act, which is promoting a lot that hydrogen scaling in the US. And so that's been dealt with. On the product side, so we've been flying the largest aircraft that you can fly with a fuel cell powertrain, so emitting truly only water from the aircraft as an exhaust since March of last year. And so that's been remarkably flying. The next step is the certification with the FAA, which is planned for the end of 2026. So we're retrofitting existing aircraft in order to go to market as fast as possible. We're also decarbonizing the ground infrastructure at the airport. There's a lot of electrification that's happening on the airport, but there's also a lot of issues bringing up the grid power to what's required to actually move everything to electric. So we're providing, again, true zero emissions solution with hydrogen to be able to charge these battery electric where there's no infrastructure to be able to support that. And so in terms of the last step, which is how do you bring the hydrogen from the source of production to these products, is what we're known as is the Nespresso of the hydrogen industry. Because we move hydrogen in capsules, in modules. We fill these modules with gaseous or liquid hydrogen at the source of production. And that can be, for example, in the LA area, there's a lot of new projects that are being built in Kern County, so in the Lancaster area, Mojave area, because there's a lot of sun, wind. So we fill our modules with hydrogen. We transport those with existing intermodal freight network to the airport. And we use existing cargo equipment to be able to load these modules or these capsules onto the aircraft or onto the ground equipment, which means zero infrastructure to be deployed on the airports, which makes every airport hydrogen ready immediately, and therefore unlocking that potential to move hydrogen. As an example, so this is a turboprop aircraft. So this is a 70-passenger aircraft that you can see here. You can see the liquid hydrogen modules that we use, that we bring from the production of the hydrogen to the airport, and we load these modules onto the aircraft, and then just connect them onto the aircraft to be able to fuel the aircraft. And we do the same thing for ground applications on the airport with gaseous applications in that case. We try to always use the best, I'd say, technology for the best for the different application. And just in terms of the company, a couple of words. So we've been flying the aircraft since March of last year. So very successfully with hand in hand with the FAA. We have 250 orders to convert aircraft, and that represents roughly $3 billion of backlog from the conversion plus the fuel service. Because at the end, it may look like we're an aircraft company, but we're actually a hydrogen fuel service company. We're just using the aircraft as a means to pull the demand of the hydrogen to convert the industry.
Wonderful. Thank you so much. It's great being with you guys here because we have the whole policy lens, where hydrogen fits in from the whole kind of decarbonization perspective. We have how do we get hydrogen to where it's needed, and the perspective from a very hard to abate sector, right, in aviation. So it's really great. I wish we could be up here for 3 hours and dive deep into this, but we're gonna have to start with the question I'm obligated to ask. The IRA was passed in 2022, and that's really accelerated decarbonization in kind of an unprecedented way in the US. And I'd like to start with you, Arnaud, and hear how has that impacted your business? How has that changed your approach? Maybe how has that changed how you see the approach to raising capital?
So I think the IRA was a great push and brought the US ahead of the pack in terms of being able to bring hydrogen in the market. It definitely brought the US ahead of Europe, which had to catch up within bringing their own policy of the European Hydrogen Bank, and bringing the cost of hydrogen more or less. The cost of hydrogen will naturally decrease with the scaling of the industry and the improvement of the technologies, but it brought the cost 10 years ahead. So what I love about it is that it's not faking the market, it's bringing the time of what the economics will be in 10 years to today to be able to speed up the introduction of hydrogen. So how did it change our perception? It changed our center of focus of where we will launch first. It changed it from mainly, as a European base. It's true that today in Europe, the ecological or the eco-friendly mindset is a little bit stronger than in the US, and therefore the willingness to enter these markets is stronger in the Europe, but the economics are better now in the US. So that's what it changed, is like the geography strategy.
Great. Well, we're glad to have you in SoCal, and sorry you have to fly back to France all the time. Maybe Jawaad, you can go next and talk about how the IRA applies to you and how you see that accelerating the transformation of your business.
Yeah, a lot of great points from Arnaud. I think the only thing I'll add to that is, to me, it was a strong shot in the arm for hydrogen. I think a lot of folks that have been involved in hydrogen for years, we're talking about some of the uses for it and some of the benefits of hydrogen, but there was really not anything that was supporting it from a federal perspective or from an investment perspective. So I think getting the IRA and getting some legitimacy behind hydrogen was super important. And just like Arnaud mentioned, it changed our focus from thinking about production of hydrogen and uses of hydrogen to, okay, well, wait a minute, we're going to need some sort of a transport function for hydrogen. We're going to need a backbone for hydrogen. You can't truck it everywhere. So for us, it really focused in looking at how we can provide a solution for this potential problem. And with the IRA, the way it was set up, we saw $8 billion of potential funding for 7 or 8 hydrogen hubs in the U.S. and in California being selected for $1.2 billion of that funding really gave that legitimacy of hydrogen and obviously the need for infrastructure. So we've been super excited. I think it's helped the state of California also, focus in on hydrogen and helping from a policy perspective.
Great. I'm sure all the students here are happy to hear that SoCal is becoming a hub, and maybe they don't have to leave sunny Southern California once they graduate.
Yeah.
Kind of same question to you, Julia, but I'd love to hear what you see as what's next after IRA. What more do we need?
Oh my gosh, can we just do IRA first? Yeah, I was like, I'm an ambitious person, but I think we just need to do IRA right. So I'll tell you a story first, and then I'll tell you a little bit about how IRA has changed what we're seeing in the industrial decarb space. The story is that we applied for this $24 million grant from Bezos Earth Fund before the IRA passed. And we had a 10-page memo, and Jeff read it, and it was all about how do we get 20 projects to final investment decision by 2024 to 2026 using hydrogen, using low carbon fuels, using carbon capture systems. We got the grant. 2 months later, the IRA passed. And so we spent the past year trying to explain to our funder that they were still supposed to give that $24 million and that we did something additional beyond what the IRA could already do. So we're trying to tell this impact story. So it has made my life significantly harder to show impact in some ways. But actually, in reality, what the IRA has done has been completely game-changed the US versus other markets. A couple of things that I would point out. The IRA usually gets most sort of like the flashy news is about the grants, but the grants is not actually the largest part of the Inflation Reduction Act. The $8 billion that went towards the hydrogen hubs were mostly $7 billion towards supply of hydrogen, another $1 billion towards demand creation for hydrogen. The loan program is much, much larger than that. And then the tax credits are really where you see the majority of the Inflation Reduction Act come. And that has been what's actually materially changed the amount of hydrogen production we're going to see in the US. It's that $3 at a maximum production tax credit for green hydrogen. What we've heard from the project developers we're working with is, and let me just say actually, so as part of this, as part of our project, we mapped industrial decarb projects across California and Texas. We found 180 investments of $500 million average size of investment. That's sort of ridiculous, because if you talk about $500 million versus the $8 billion, grant projects, like how many projects can we actually do just with grant funding? So the point being there, that when we sort of mapped out these different projects, when we talked with project developers as we're starting to work with them, grants are okay, they're not sufficient. Even the loans, the public loans, are not going to be sufficient for doing many of these much larger projects. We're going to have to see private capital get much more activated. So we've been doing things like meeting with financial institutions, talking them through what does stacked tech risk look like? How does hourly matching and the requirements of 45V, for example, actually change what types of projects you have to finance and how you have to finance them? And then finally, I would just say, what the IRA has done for community engagement is in my mind, one of the things that's game-changing about the IRA. We have worked with many of the companies in the industrial and decarb space on understanding Justice 40, on understanding environmental justice period, on understanding equity period. And what we've heard as direct feedback is we were doing community engagement before, and we were doing it completely wrong. Now that we have better guidelines, now that we're understanding even what the government is asking of us, now that we're better understanding what community groups are asking of us, it is helpful to understand this is not just a cost, this is table stakes. You have to do this in order to do industrial decarb projects. So in any case, IRA, I think, has been really helpful for the US. It's also made our products more competitive to be exported. I think from a policy lens, one of the things we're hoping to see is that this is not just a national policy that's replicated. We need subnational policies, state and local government policy that falls in line. Because especially if we're talking about California, we have a permitting issue. I'm saying this to the crowd, or to the chorus rather. And so, we can't, and I feel weird saying this because I was also in government, but we have to go with the right speed, not at no speed.
That's a great answer.
Yeah.
Do you mind me bouncing on?
Yeah.
So you mentioned something on the production tax credit.
Yeah.
I think the guidance of the production tax credit can also completely change how it's implemented and where actually the goals are. To give you an example, there's three major criteria. There's the hourly matching, which means that the renewable energy has to be produced roughly in the same hour as the production of the hydrogen. So that means that solar in the night is an issue because you cannot do it. There's regionality, it has to be in the same kind of location. And then there's additionality. And additionality means there has to be new infrastructure that is put in place. And to give you an example of how it's impacting directly myself is that we were talking about the US Northeast and California. US Northeast is mainly hydro. Hydro, is not additional, and therefore the production tax credit, you create wonderful green hydrogen, zero emission, but you can't apply that to the production tax credit in the US Northeast because your renewable energy is not additional infrastructure. And that's a huge burden because that means the US Northeast won't see the benefits of actually having clean hydrogen aviation or other production. And so these subtle guidance rules are going to decide of actually where in the US are going to be the major poles of production and therefore usage.
I'm sure, Jawaad, you have a perspective on that, considering a big project to try to bring renewable hydrogen into Southern California.
Yes, and I think California is unique in a lot of ways. I think so the projects that we have in California are green hydrogen or clean hydrogen. So that's a little bit of another level of complexity when it comes to additionality in new projects. As we were thinking about this infrastructure project, which is essentially a match producers of solar and wind, where you have a lot of curtailed power. A lot of curtailed power happens when there's not a match for solar or wind into our grid. We end up selling this power, usually pennies on a dollar, to Arizona or neighboring states. The goal would be to take that power, the curtailed power, and have an electrolyzer on site and create green hydrogen. Now, as Arnaud mentioned, then we have some rules that go on top of that. So what we're trying to avoid is creation of solar facilities only for the sake of creating green hydrogen. That goes against what we're trying to do from a sustainability perspective. So there's ways to look at those rules and see how they apply. I mean, the the example you gave is a great one because it also applies to the Pacific Northwest, where California takes a lot of imported power. That's clean power based on hydro. As more and more states have their own net zero goals, we're at 2045. Washington has their own goals. We're seeing less of those imports coming in. So there's a higher need for that in-state generated power, and we're thinking green hydrogen is the way to do that. But we have to get over some of the rules that came out of this place. The solar producers that are seeing the funding, that are seeing a project, they're super excited because they need a way to arbitrage that additional power they're getting, whether it's maybe for aviation purposes, you take it away in your infrastructure, or use it to put back into the grid, or store it on site using pipelines. So a lot of options, but the rules are complicated. I think where there's a lot of work happening in Washington, we'll see. Hopefully, there's some cooler heads that prevail afterwards.
We all hope so.
Yes,
We all
crossing
hope
our
so.
fingers. Yeah.
Maybe a little curveball at you, Julia. I'm interested in.
Sure. Yeah, let's do it.
In building big infrastructure, it requires a lot of communities to host energy resources where maybe they didn't have to host them before.
That's
and I know you guys are
yeah.
deeply engaged in the policy side, and you said now it's table stakes, right? That level of engagement.
Yeah.
How are you helping maybe companies, organizations navigate what is now table stakes in terms of?
Yeah, no, it's an awesome question. We're doing it in a number of ways. So the IRA, again, the Biden administration has really created frameworks for thinking about community engagement in a different way. And they use, two things, two mechanisms, which are not new, but they're new as being table stakes for applying to grant funding. One is community benefit plans, and the second is community benefit agreements. So community benefit plans are plans for how the community is going to benefit from the investment you're making in clean energy in their area. It's often workforce related, so it's how many jobs are being created in that area. It's training programs. It's what the wages are for those. The community benefit agreements are what's legally enforceable. So that's what you sign and can get sued for if you don't do. What we're doing with the companies themselves is often the people who are developing community benefit plans at companies wear 7 hats. And one of their hats is community engagement, but it's really external relations, or it's usually government affairs. And so they're doing a phenomenal job, given this is a 7th of their job, but understanding the new requirements for community engagement are quite different. So we do a fair amount of actually education and training across companies. This is something that's not competitive. We can't get a couple of hydrogen producers in the same room and talk about a lot of things, but we can get a number of companies across the spectrum to get in a room and talk about community engagement, because this is where everybody benefits when community engagement is done better. So education, training, workshops. We have also started to come up with metrics of what your community benefit plan should look like. So what are, floors and ceilings for some of the things that I mentioned in terms of numbers of jobs, et cetera. The next stage, and this is the stage that everybody is experimenting on, is how do you bring companies together with governments, with community groups, in order to create this sort of productive third space where it's not as antagonistic as it has been in the past. Certainly there have been harms, and certainly there have been investments that have been made that did not go well, and certainly there's been pollution, and it's not that there will be no pollution when there's other clean energy investments made, but it's about thinking about, again, how do you go at the right pace rather than at no pace, or rather than at too fast a pace. And so some of the things we're starting to think about now are how do you bring those cohorts of groups together, and also how do you start to quantify community benefits in a way that companies no longer think this is a cost. This is something that is just going to cost me money, rather than this is something that's really going to save me money in the long term when my $500 million project doesn't get canceled because I've had 10 community groups come together and sue me, which, if you want a list of projects that have been canceled, yeah, there's a lot, and it's growing.
Yeah, that's a great answer. Now it's the audience participation portion, but I'm just going to have one quick question. Who in here is a current student, whether at UCLA or somewhere else? So a lot of them. And I think we're going to get to specific advice maybe from the panel about where you guys see business school students and other students fitting into this new ecosystem. But maybe I'd love to hear from you, Arnaud, about how are you going to transition the workforce generally in aviation away from kind of a fossil-based technology, infrastructure, et cetera, towards the new future as you've outlined?
So so there's two kinds of workforce. There's the workforce that are on the, say, the development and the major aircraft manufacturers and all of that. They're super excited because what they see is the aerospace industry is exciting, but it's been the same for 30, 40 years. And like the new generation of people, of engineers, of business leaders, they want to see the change and they want to see a revolution in terms of emissions. So that one is actually pretty easy to move forward. The one that's harder in terms of education and workforce is more the operating people on the ground, for example, that you have to educate. So that's why in the way we're transitioning aviation, we're starting off with that ground power system in order to educate the people on the ground at the airports to how you do manage hydrogen in a safe and simple way in order to do a stepping stone to then manage the hydrogen aircraft. So we try to bring it in more or less in different steps so that we bring the communities in and we bring the airport in. And when you bring the community and the airport, you also bring all of the cities around because you're creating zero emission, you're getting rid of diesel, of all of the local air quality issues. So you're bringing up the whole area around the airports and creating great momentum.
Fascinating. It's fascinating how you have to touch every single part of that chain to make your business a reality.
Yeah, that's why I mean it's often hand in hand. It's a win. It has to be a win-win-win. And I don't know how many wins. But there's a lot of hands that are in the pot to make it work. But everybody wants to actually get there because the objective is where we need to go. So there's a lot of collaboration, and it's an environment that's thrilling to be in because people want to make it happen.
Well, maybe a kind of similar question to you. You know, SoCalGas has been around for a long time, and your core business is natural gas, and there is a transition in technology and competence in people. How do you see that shaping up for your future hydrogen endeavors?
Yeah, no, it's definitely, so again, similar. We've got folks that are super excited, that are in the engineering space, that are in the creative space as far as these new energy delivery systems. The flip side, as we're looking at using existing infrastructure, existing pipelines, or new pipelines like the one I explained, a lot of the functions are going to be very similar. You've got a relevant pipe, you've got creating compressor stations. So a lot of the jobs will be there, but there's a safety aspect of hydrogen. So you've got to get retrained, you've got to get redeployed from that perspective. And part of that is something that Julia made a really important point, which was the inclusive communication. So a lot of these communications we have, like we're having today, we're having in our company, we're talking about a new project, we're including labor. I think the unions are super important in being part of the conversation early on, so they're understanding exactly what's happening. Because everybody's really thinking about, what does this mean for me? Right? And we've got AI going on too, so it's like there's two different things coming our way. But really it's inclusion, education, and knowing that some of the jobs may change. You may go to Cameron, your house, instead of working on your water heater, maybe there's a fuel cell that our technicians working on. You can train for that. How to understand battery systems, because a lot of the homes now have batteries next to the water heater. So there's some training, deployment, technology, but it's not going to be easy. There's just a lot of communication, a lot of education, a lot of inclusion. Yeah.
Now's the fun part where I get to ask for advice on behalf of everyone in the audience. I know every time I read a white paper from RMI, I want to come work for you guys.
Great, yeah. You're welcome to join.
What advice would you have? Like, what skills do you think are important?
Yeah.
One, to be in hydrogen, but two, to be kind of a contributor at a high level in this transition generally?
It's a great question. Whatever path you want to take. I mean, really, I think, and I say that not as a cop-out answer, but what I really mean by that is there are so many ways in which people are going to be able to find jobs in climate. This is a hugely, hugely important sector, and so is hydrogen. So you can be an engineer, yes, but you can also specialize in policy, you can specialize in finance, you can specialize in technology, you can specialize in community engagement, and each of those things mean 100 different things. Just to tell you a little bit about my path, I'm an economist and an urban designer by training. I was really passionate about transportation. My background was on passenger on-road transportation. So that's sort of the lens that I brought into all this. I worked for Siemens, so a global infrastructure and tech company, and worked on pulling together those really large, clean infrastructure projects. I went into the mayor's office. I worked in LA, and I worked on sort of the policy side of things, but thinking about sustainability. And then I found myself at RMI because I wanted to zoom out and be more globally focused. So I think kind of the way in which I orient my career works for me, might not work for other people, is I've thought about what impact do I want to have, and then I put the pieces together and try to think about how do I want to do that from the perspective of a really large company, how do I want to do that from the perspective of local government, and then how now do I want to do that from the perspective of nonprofits, and who knows where I'll go next. But in any case, you know, there's sort of many ways in which you can have impact. I think deciding what kind of impact you want to have is most important. With that said, I will say in the hydrogen space in particular, what we found has been relevant in the US and actually in Europe too, is policy folks. So people who are either actively lobbying or who are thinking about what are the right policies to pass at national and subnational level. Finance, it's project finance. We have so many banks that we are working with that do not have hydrogen experts on staff. And so they are basically contracting us, or they're trying to read as many white papers as they can to get up to speed, and it's on the debt and the equity side, and it's across all types of equity too, so private equity, et cetera, venture, even if you consider that not for project finance, but just for startups. And then on the tech side, again, a slew of opportunities. There are many, many project developers who are just in California. Sometimes they are 3-people shops, and they have done renewable electricity projects. They've never done a hydrogen project, and it's not the same. So being able to have sort of that expertise brought in is really important. And then, of course, there's the Chevrons and Shells of the world that are doing some of the larger projects. So again, more, there's enough work to go around, certainly. That's really, I think, about matching what your own set of interests is against what the job requirements are.
That's great advice.
Yeah. Thank you.
Arnaud, you bring a lot of operating experience and a lot of domain expertise, right? Having been in aviation for much of your career. When you're looking at growing your business, what kind of business talent are you looking for?
So I think so first, just to complement what Julia was saying, is that hydrogen is a nascent market. There's so much opportunities that just dive in and you'll find your place. And the growth is going to be really, really significant. So when I moved so I've always wanted to actually to be in the green energy business. I had a choice when I finished my master's between aviation and green energy, and I chose aviation, and I've always wanted to go back, say, I want to go to green energy. I was like, how can I sell my aviation experience in that green energy world? And I was never able to until 3 years ago, where the planet starts to align. My background's aviation. I have no hydrogen experience, but the number of people who have hydrogen experience right now is relatively low.
Yeah.
You become pretty quickly an expert, but so don't hesitate. You don't need to have a huge background in hydrogen in that space in order to actually make a dent, because it truly lacks a huge amount of people across the board, as Julia was mentioning. So don't hesitate to take the risk. There's almost, maybe if you take a risk, that's what I said to myself. Hey, if I'm moving from a large corporation to a startup, but I'm going in the hydrogen space, so my risk is actually zero. Because even if the startup fails or whatever, I'll be in the hydrogen space, it'll bounce. So don't hesitate, I'd say, to take major risks and going into that direction. You'll find your way wherever that way is.
Great advice. I like the zero risk pitch. It's no risk. You heard it here. Jawaad, you have to follow up some great advice, but
wow.
Same question to you.
No, it's really good advice there. I think the only thing I'll add is similar to the backgrounds here. I'm a CPA. I'm in the hydrogen space. Should have paid more attention to the periodic table in chemistry class. It comes up a lot. I'd say, I think the finance aspect is big with the IRA. I think trying to understand tax credits and project finance is super important. Being able to tell a story is also super. I didn't realize how important it is to be able to tell a story about what you're trying to do, what your technology is, and how to explain very complex technological terms, whether it's electrolyzers, splitting hydrogen, or the aviation piece that Arnold talked about, being able to put that in a way where you can sell that story to financiers, to public organizations and whatnot. And lastly, what I'll mention is, whatever background you have, MBA, engineering, whatever the case is, I think being able to communicate at various levels, especially with the community. Julia, you mentioned this was never my job description, 10 years ago, but the amount of interaction you have with CBOs and other local organizations, and really shifting the mind about it's not just, giving a donation and cutting a ribbon and just, driving off. It's really by investing in the community, showing the community how these investments are going to help them long term, not only keep the jobs they have, but create new jobs, and best of all, reduce the GHG impact. So really the communication aspect comes into whether we're in policy, finance, engineering, or operations. It's storytelling, it's communicating, it's relating, and really showing that picture of where you're trying to go from A to B and how you bring everybody along with you.
Great. I love hearing how important engagement with the community is becoming for what is an industrial business. That's really great to see.
Absolutely.
We might be a little early, but I know a lot of you probably have some questions, so I'd love to open it up to the floor. I'll start and work this way. We'll see how many we can get through.
All right. Thank you for your time and insights. In terms of community benefits, while hydrogen and green hydrogen or clean hydrogen is carbon-free, there often becomes a concern from some communities that when combusted, it can emit nitrogen oxides. And so any insights as to what your research or company efforts are doing to mitigate that, or even to educate the community and maybe assuage some of those concerns?
I want to hear your answer first.
Yeah. No,
You
absolutely.
explain this.
Yeah, that's probably the number one or two question we get versus, safety is probably number one. How do you, everything you hear about hydrogen 10, 15 years ago was safety issues. So those are questions, but NOx is a big question, especially when you're looking at the combustion aspects of it with heavy duty trucking, whatever the case may be. I think two things. When it comes to transport, it's a little bit more of a straightforward conversation because a hydrogen fuel cell, heavy-duty trucks don't have combustion, right? They're more of a, you're really just draining energy that's created through a chemical reaction, right? So that's a little bit easier. I think the conversations around combustion we've had, or the NOx, is around power plants. I know LADWP has a goal to start blending hydrogen into some of their power plants in the basin, and that's been a big question about the NOx levels of 0.02 and how do we get that better. So as an industry, not just us as a pipeline operator, but manufacturers of the equipment like Mitsubishi who are working on some of those new turbines, other partners in the industry and BP and others are coming up with ways where we can get that down below 0.02. I think we're very close. There's a lot of work that's happening today to see how we can get that all the way down or capture it on site. And use that product for something else. So definitely a big question, but a lot of folks are working on it. It is a concern. And we usually try to separate the conversation between the fuel cell aspect, and sometimes it all gets rolled into one. And it's really, here's the combustible uses for hydrogen. Usually it's power plants, some industrial reasons as well. On the industry side, we do start also compare with other aspects like, GHG emissions do come down. NOx do come down, but they're not completely gone. So a lot of work, a lot of research about that. But yeah, it's a fair concern, and the industry is looking at it.
Arnaud, I think you framed the 45V problem nicely with Northeast versus Southwest. The environmental community sees 45V as right and don't want to see any relaxation, and the other side sees it as an impediment to development of the hydrogen ecosystem. What do we do to bring that into the middle so that we can get some relaxation to service the Northeast, with your example, and not let go of the entire market?
So I think we need to make sure we target the objective, the end objective, and we actually tweak the guidance to meet the objectives that we have. For the moment, it's more. It gives the impression that it's more focusing on a technology than on an objective. And I think we need to recenter a bit, and that's what we're doing on the lobbying side, is like recenter to what is the objective in terms of decarbonizing which industry and how to do that, and how to relax these guidance to be able to do that, versus trying to promote this or this technology, which generates these kind of guidances. And so we've been applying a lot of effort to go into that direction. To be fair, the aviation sector is not the primary concern today of the 45V. It's mainly on the chemicals, industrial refineries, and heavy-duty transport for trucks. So our lobbying has a limited impact, but we need to.
But you have to do it anyway.
Is RMI?
We can't lobby. As a C3, we can't lobby. So we can make policy suggestions. We can file comment papers, but we're not up on Capitol Hill knocking on doors. Is there anybody from an electric utility in the room? Okay, I'm going to say this anyways, but I think one of the things that is important about 45V and incrementality, additionality, et cetera, is we need a better plan for electric utilities in the US about power production. And we need to not be only building behind the meter power for all of these new loads coming online. And so my hope is if this regulation doesn't change, if it doesn't shift, really what it spurs is the public utility commissions, the ISOs, all of the electric utilities to do what they're supposed to be doing. No offense intended, in terms of actually planning for a clean energy future, rather than, again, working at like no speed rather than at the right speed. That's my personal opinion, I should say, too. That's probably not something I should say on behalf of everybody. They'd be like, Julia, shut up. It's not recorded.
I love hearing planning. Yeah.
Yeah, so my question's more for Jawaad here, but I'm kind of curious, how do you kind of think about making, I guess, like the role of hydrogen, particularly in its development, into this like new frontier of energy production, such that it translates to an actual energy transition, and not just an invitation for additional capacity use. And then maybe, I guess, for Julia and Arnaud, you talked a little bit about the necessary infrastructure that would have to be built in order to scale hydrogen. So how do you think also about the additional energy needs for that, and how that might not actually go to replacing, but increasing our energy needs?
Okay, great question. I'll probably give a very simple example of trying to create that realness or that demand or that end use for this. And it has to do with signals. So we started talking about the IRA package that came out, strong signal for hydrogen being a carrier of fuels. Then the state of California, through ARB, their scoping plan, the CEC through their integrated energy planning process, IPER, all started talking about the need for hydrogen for not only hard-to-abate sector, but also for power generation. Now, a signal to send to end users that have large investments sitting on the sidelines, and they're wondering, okay, should I go ahead and buy that super new, fancy, expensive Mitsubishi turbine for my power plant or not? And the way to signal that is in the state's renewable portfolio standard, the RPS that we have in Senate Bill 100. There's a definition of what a renewable energy generation source is. It counts solar, it counts wind, it counts batteries. Right now, on clean hydrogen, it's a question mark. So we're interacting with agencies and whatnot. If there's a direction that says, hey, we believe clean hydrogen generated from the right sources can be used in power generation and counts towards the RPS goal, that's a huge signal. Then you have power plant operators that can say, okay, I can invest in this new technology. I can start procuring hydrogen, create that demand. Some of that demand can flow over into other industries as well. So that's sort of the way that we can get this started. So it's not just a conversation, or it's not a nascent technology. There's an actual end use that's supported by policy, very similar to where the solar and wind industries were 20 years ago. Once we put the RPS standard and said solar and wind are part of the portfolio, investments started coming in, we got tax credits, and the cost came down as well. So that'd be an example of how I think I can see this moving forward.
Thanks for that answer. I think just for the sake of time, considering there's many more questions, if you don't mind, we'll skip to the last few and maybe connect with the panelists after. I'm going to start with someone on this side. Back.
I'm pretty new to all of this, and I think this has been really interesting and cool, and you guys are explaining the way that's exciting and digestible. So I hope this question is on right. With solar, it kind of, at the residential level, it really can create this level of participation and investment in sort of that drive. Is hydrogen something that would potentially reach that kind of more residential participation? And is it a potential alternative for example, like just a residential solar system that could produce more than what is allowed because of being connected to the grid and potentially using that to generate fuel?
Great question. I'll take a quick shot at it and then jump in. So I think one of the things that we're seeing in a lot of the studies that we're looking at is hydrogen fuel cells, which would be using solar that's produced, can be effective in new communities. For example, if there's a new community that's going to be fully electrified, out in the Inland Empire, and the cost of building new electric infrastructure is astronomical, and you need that resiliency for those high heat days or wildfire events, you can have a fuel cell that's on site that's using solar that's generated by the community to create hydrogen on site and use a fuel cell to use as backup power for multi-day events. It can also charge the batteries that are in your garage. If you have Tesla batteries or whatever the case is, they integrate. And some of the high heat that gets created off of that process can be used to heat the pool, for example, the community pool. So I see a future where maybe it's not in every home, but for these large communities, large buildings, you can have a fuel cell that's operated and generated on site to create that resiliency for that neighborhood.
I really like this question because I'm boiling it down to, can you crowdfund, hydrogen investments? And also, can you crowd capture the benefits, right? And so I think the types of projects that I'm working on, the answer is no. You're not really crowdfunding the hydrogen projects because they're so large and it's not really meant for individual residential buildings or individual residents or individual people. It's really meant for these much larger industrial applications, things like steel, things like cement eventually. With that said, though, what we're starting to see is more potential for co-ownership of assets that then benefits the community in a slightly different way. And that, I think, is really exciting. I'd say start to see. I would kind of emphasize that because we don't really have any, I can't tell you a case study about that. But in terms of sort of crowdfunding or really directly applying solar, the solar example to the hydrogen example beyond fuel cells, which I don't think we'll see at every house or in every apartment building, probably, not the right metaphor to use.
And just to jump on that, I think one of my mottos is we have a limited amount of energy on Earth, and we need to use the right energy and the right technology for the right applications. And when you look at hydrogen, from renewable energy to creating the hydrogen, it's a 70% efficiency. And then from moving back to the hydrogen to electrical power, it's a 50% efficiency, and 50% is dissipated by heat. So it's not as if you go from solar to battery. Solar to battery and to directly to power is 95%. So you lose a lot of efficiency in the process of creating the hydrogen. So you got to use it for a really high load application where battery and battery electric is not the solution. If you're able to use battery for your application, you should definitely use battery for it. So I think it's really try to find the sweet spot of where this energy and this method makes sense, and not to try to apply it to every case that exists.
Yeah, really trying to find those hard to abate sectors and pursuing the ones where hydrogen is the best fit.
Well,
it's really fascinating.
One typical example is that this is not my company, but I'm personally not in favor of hydrogen cars because the power requirement and the energy requirement is not enough to justify a hydrogen and can be solved by battery. So it should be battery electric and not going to hydrogen. The only niche is for people who like to have combustion hydrogen in order to keep cars that do loud noise and low emissions. Okay, so that's a
Maybe it's
niche.
a win-win, maybe it's a lose. Yeah. Any more questions?
Yeah, curious to know, how are existing natural gas, or how's that infrastructure to be retrofitted at all to accommodate hydrogen in the pipelines? I've heard that hydrogen is much more complex to deal with compared to natural gas. So can you use the existing infrastructure, or do you have to rip it all up and put down new pipelines that are meant for hydrogen? And similarly for natural gas generating facilities, can those boilers be retrofitted? And is that being considered, or is there going to be complete new infrastructure?
Yeah, great. All the above, I'd say, right? So let me start with existing infrastructure versus new infrastructure. So, the studies that we're looking at and what's happening in Europe and what we're seeing across the U.S., there's pretty good consensus if you're going to build a transmission backbone, which is hundreds of miles to bring hydrogen from source to a demand center. A new infrastructure, a new pipeline is probably the best way to go. Now, when you're looking at infrastructure that's in basin, really depends on the age of the infrastructure and the type of infrastructure you have. The newer the infrastructure, and if the infrastructure is plastic pipe, for example, that is much more easier to blend into hydrogen. Some of the older pipeline, mostly down in California, I think East Coast has a lot of old iron pipes. You don't want to repurpose those for hydrogen. Those are not set up for that at all. But before we do any of that, that's where I think I mentioned earlier, the California Public Utilities Commission has asked the gas utilities to start doing demonstration pilots on blending small amounts of hydrogen into existing infrastructure from a safety appliance perspective. We've tested appliances up to 20% hydrogen blend, and they seem to behave normally. You go above that, and that seems to be the threshold. Hawaii right now has been blending hydrogen in their system for about 50 years now. They're about 15% hydrogen. So if you have a cheeseburger in Maui, it's cooked on a small blend of hydrogen flame. So there's a lot of work being done. I think from an affordability perspective, it makes a lot of sense to look at that infrastructure. We pay for that infrastructure. It's safe. It's underground. It's impervious to a lot of things that happen above ground with wires at times. But there's a lot of testing, a lot of demonstrations.
Can I add on to this?
Yeah,
Okay, I would say this is one other area where coordination is key, and also nationally. What we're seeing happening is that some of the coordination around pipelines is happening within states even. And when you're talking about the hydrogen market, it's not going to be just intrastate, it's also going to be interstate. So it's going to be really important to look at an entire backbone of pipelines. One of the initiatives a colleague of mine is running at RMI is called the North American Hydrogen Backbone, and it's sort of modeled off of something that had already happened in Europe called a European Hydrogen Backbone, where they basically came up with a plan of what pipelines needed to look like in Europe. We definitely need the same thing here. I think the problem that I'm seeing in the US too, even with the Inflation Reduction Act, and actually especially because of the Hydrogen Hubs grant money from Department of Energy, is we had 7 teams win, and they all have different plans as to which sectors are going to be the first to use hydrogen. And there's like a little bit, there's like overlaps.
And the color of hydrogen as well.
And the color of hydrogen, which come in ice cream flavors. It always boggles my mind how many.
Always a new one
Yeah,
too,
there's
yeah.
always a new one, and we can't wait to move away from it. In any case, so again, I think taking that step back and figuring out what's the goal here, and what does the size of the investment need to be across the country is hopefully what happens next if we're going to go for something after the IRA. It's maybe like a pipeline bill.
I'd love to see a transmission bill and a pipeline bill. Maybe we can bundle
There you
those
go.
together.
Yeah.
Call it good plan.
Yeah.
Any more questions from the audience?
I was just curious to understand the financing structure behind these technologies, and it probably goes beyond hydrogen as well. But my concern is that since a lot of this funding is coming in from private equity and maybe venture, how do you ensure as part of the industry that profits or other financial motives don't get in the way of the actual development that's needed?
That's a great one.
So I'll take a stab at it, knowing that we're in a phase which is an awkward phase, and a lot of the hydrogen industry is in that phase between the VC and the private equity. So VC is funding a lot of new opportunities, new technologies, all of that. Private equity is funding what's reliable and scalable and capability to get a guaranteed return on investment. And a lot of the hydrogen industry is like in the demonstrator and initial scaling, which was in between the VC and the PE. And 2 years ago was not struggling. There was free money, so it was available. Right now is a lot more difficult stage for all of these companies to grow. And it's actually a little bit doing what you're saying, is like preventing the industry to scale as fast as it can, because there's no financing infrastructure that really responds to that middle ground. So it takes longer. I mean, money's there. It takes longer. Unfortunately, it's also for the US local economy, it's also money sometimes coming from abroad, because there's less shyness, or there's to do the investments from Middle East or so it's changing a little bit the dynamics. It takes a little bit more time to get the financing, but it still happens for the good for the companies that have real potential.
I think that might be it for time, if I'm not mistaken, but I really wanted to thank all of you and thank the audience for joining and having great questions.